The motto of submarine services worldwide, we come unseen, and because of the nature of their work, little is common knowledge of their operations, of their service, and of the people that man them. Unfortunately, submarines are only in the news when something untoward happens, and then everyone who's never been on one is an instant expert. Many years ago, I was training on a newspaper and an old fellow said to me, "Do you want to be a reporter or a journalist?" And I said, "What's the difference?" He said, "A reporter reports facts, a journalist tells stories." And I would remind you that if you don't get the news, you're uninformed. If you do get the news, you're ill-informed. The Australian Submarine Service has been around for quite some time. I'm sure a lot of you are aware that we have submarines down at Garden Island here. They started from the inception of the Australian Navy in 1911. Among the inventory of Australia's ships in the first fleet, if you like to call it that, were two submarines called AE1 and AE2, Australian E-class submarines. AE1 disappeared on the 14th of September 1914 off Rabaul. The submarines had been sent to north of New Guinea to report on German interests in the area. On the 30th of April 1915, AE2 was sunk in the Sea of Marmara in Turkey. She had been attacked by a Turkish gunboat called the Sultan Hazar, and the captain, a fellow named Henry Dacre Stoker, ordered that the submarine be abandoned and the crew were interned as prisoners of war. The submarine is still there to this day on the bottom of the ocean. In 2017, the wreck of AE1 was found off Rabaul. Its position will never be revealed because they don't want people to go and pull bits off it and disturb the grave. I'm going to tell you a little interesting story about AE1 and me. The captain of AE1 was a British officer by the name of Thomas Besant. He transferred to the Australian Navy upon the inception of the Navy and came to Australia with AE1, and he lived in suburban Sydney for a few years. In 1971, I went to the UK for my initial submarine training, and when I returned about a year later, my wife and I settled into a house in a Sydney suburb called Croydon. Croydon is a very old suburb, houses built in the 1880s to 1890s. And we lived in a lovely old house there for several years. Some years later, I was doing some research on AE1, and to my absolute amazement, I found I'd been living in Tommy Besant's house for 2 years. So I have a connection. After World War I, Australia was again without submarines and purchased 6 J-class submarines from the British. The J-class submarines were in very poor mechanical condition and spent most of their time berthed at Geelong, where they served as training vessels for engineering apprentices. The J-class served until 1922, when they were all decommissioned, and several were used as breakwaters at various yacht clubs around Port Phillip Bay and can still be seen there to this day. Australia then went on to buy 2 O-class submarines from the British. These were, at that time, the best, the latest submarines, very, very efficient. But by 1930, with the Great Depression ripping into Australia, they found they couldn't afford to keep the Navy that we had. Something had to go. So the 2 O-class submarines, Oxley and Otway, were returned to the United Kingdom. Oxley, in 1941, was unfortunately sunk by another British submarine. During the war, however, submarines remained in Australia. The US Navy used Fremantle as their submarine base for their Southwest Pacific operations. It's a little known fact that during World War II, Fremantle was the second largest Allied submarine base in the world. Between 1942 and 1945, there were 122 American, 31 British and 9 Dutch submarines based in Fremantle. They accounted for 340,000 tonnes of shipping. During the war, the American submarine fleet sank more Japanese shipping. In actual fact, they sank 16 times the amount of shipping by all other methods combined. Very devastating, very powerful vessels. Of course, at the end of the war, they went. Everything was taken, everything left. But the British remained. The British had a submarine tender called HMS Adamant. It was berthed in Fremantle. There was another submarine tender called the Maidstone that was berthed at Alexandria in Egypt. But the British decided, let's use our submarine tenders to travel out to sea and service the submarines where they're operating. Unfortunately, Maidstone was torpedoed and sunk. They not only lost a submarine tender, they lost over 300 qualified submarine engineers and electrical personnel. They lost hundreds of spare torpedoes. They lost all the stock they had in the Mediterranean of periscopes. This was a devastating setback. The Americans berthed their submarine tenders at a port and had the submarines come into them. So the British started to do that. The submarines would be running out of Trincomalee and Ceylon, now Sri Lanka. They would patrol along the Malay Barrier and then come down to Fremantle where they'd berth alongside. After the war, when all the submarines left, so did two big passenger ships full of war brides. The British remained. They kept several submarines in Australia known as the 4th Submarine Flotilla. And the 4th Submarine Flotilla served in Australian waters from 1949 until 1969. There were 4 of the old T-class submarines, Tabard, Trump, Taciturn and Tiptoe. The Australian Navy in the early 60s was looking to re-establish their submarine service and had Australian sailors serve on British submarines running out of Sydney. In 1967, Minister responsible, a fellow by the name of John Gorton, some of you may have heard of him, he authorised the purchase of 4 submarines for the Navy. The first 4 submarines we bought, the Oberon class submarines, cost $6 million, which included spare parts. In the 1970s we bought 2 more. That cost us $30 million. In the 1990s we built 6 Collins class submarines. That cost us $5.8 billion. So the price goes up. I've always said submarines are like cars. The first motor car had 4 wheels and an engine, and the car of today has 4 wheels and an engine. The only thing that's different is the shape and what goes in them. The Oberon class submarines were very successful. In fact, they were, without doubt, the most effective conventional submarine in the world. The Australians upgraded the submarines in the late 70s. They were fitted with new sonars. What a lot of people don't realise is submarines are passive. They're not active. That is, they do not transmit or ping on their sonar. They listen. You ever see a movie where the submarine's pinging away on its sonar, even if John Wayne's in it, it's a load of rubbish. They don't do it. They listen. And to do that, we had an extremely sophisticated sonar suite on board. Sewn into the tanks down either side were a number of transducers looking out around the submarine for broadband noise, the noise of the ship moving through the water. Once you detected that noise, you needed to identify the ship by classifying the narrowband noise. That is, the frequency of individual machinery within inside the hull, the propeller shafts turning, the number of blades on the screws and so on. And to do that we used a sonar called the CSU, which was in the dome up on top of the bow of the submarine. A submarine sonar operator could tell you everything you needed to know about a ship other than the captain's name within about 30 seconds. They were very, very good. We had another main sonar. We had 3 panels on either side. It was called the micro puffs. That looked at each side in 3 lobes, and as a ship came within the sphere of influence of those lobes, because it approached each one at a different rate, it would use a Doppler method to calculate a range. We had more sonars on the top of the submarine and in the fin. The large structure in the centre of the submarine is called the fin. By the way, it is not the conning tower. The conning tower is actually a hatch that leads from inside the submarine up into the fin. And those sonars, I kid you not, are that sensitive. If you get close enough to a ship, we could hear people talking on board. In the late 1980s, it was decided that the submarines, the Oberon class submarines, would need replacing, and so the hunt was on to get a replacement submarine. And we settled for the Collins class, a Type 471 Kockums design, Swedish design. The reason this design was selected is simply because no one else had one. The Australian Navy is the only Navy in the world that operates the Collins class submarines. And despite what the journalists tell you, they are, again, amongst the most effective conventional submarines in the world. They are incredible. People don't understand the range of a submarine. They're diesel electric. You have diesel generators. Power that's generated is stored in 2 batteries, and the batteries provide for all your electrical needs on board. Each submarine has 2 batteries. Each battery is 224 lead acid cells, and each cell weighs over half a tonne. We have 230 tonnes of battery on board a conventional submarine. As you probably know, that is the same weight as an A380 Airbus jumbo jet. When that battery is fully charged, we have enough electrical capacity to provide for the needs of the average suburban home for about 2 years. Run our main motors flat out, we've got a matter of hours. They're 3,000 horsepower motors, just chew the juice out of the box so we conserve power. Submarines carry 380,000 litres of dieseline, and it gives us a range in excess of 20,000 kilometres, halfway around the world. I took one of these to San Diego and back on a single tank. Do that with your electric car. The sphere of operation of Australian submarines is vast, from the Antarctic to the Arctic, from Africa to the Far Eastern Pacific. Our main operational area is around the South China Sea, the Bay of Bengal, and up in the Gulf of Oman. Submarines are data collectors, intelligence gatherers. They're not out overnight, they're on patrol for about 3 months at a time. They're listening to radio and radar, they're listening to ships going in and out of ports, they're listening to all the air traffic control and missile radars, and they build up a very, very good intelligence picture of the world, and they're in great demand to do so. People don't realise this, but the submarines are basically, I hesitate to use the word hired out, but they are deployed in the service of other countries at their request to do intelligence gathering missions. We have to have a long range to get around. So the Navy decided we now need a new submarine. And in July 2007, planning for the next generation of Australian submarines began. December that year, Project C1000 was announced. The Defence Department, when they put out a project, it will be prefix C, air or land. It doesn't matter what service it is. Air is for aircraft. If the Navy want helicopters, it's an air contract. If the Army want water boats, it's a sea contract. If the Navy wants motor cars, it's a land contract. Simple as that. In 2008, C1000 was established within the Department of Material, or the Defence Material Organisation. These are the people who start ordering the spare parts, bits and pieces and so on. In 2015, a selection process was announced. Put out a what's called an RFT, request for tender, and we would select expressions of interest from various countries. They could tell us, yes, we can build this submarine, we can do this and that and the other. The options given to the government by a military off-the-shelf design, a MOTS. We've done that, we did that with the Oberons. It's a military off-the-shelf design. There were 27 Oberons built, 13 for the UK, 6 for Australia, 3 for Canada, 2 for Brazil and 2 for Chile. The one sitting on the slipway down at Fremantle is the only submarine in the world where you're going to get a personalised guided tour. The second choice was to develop a modified MOTS design to better suit Australian conditions. This is a bit difficult to do You can't just say, okay, this looks good to us, but we want it to be 3 times as big. It doesn't work that way. They could design an evolution of the Collins class, which was a viable option, or design an entirely new class of submarine. And they hit upon the last option, design an entirely new class of submarine. So they called for expressions of interest. A number of countries submitted designs. The Japanese with the Soryu class, the Germans with the Type 214, the French with what they call the short fin Barracuda, and the Swedish with the Blekinge. Now the Blekinge was rejected straight away because the only other submarine the Swedes had designed in the last 30 years was the Collins class. The German Type 214 was rejected as being too small, far too small. As you can see here, it's only 1,800 tonnes. The Soryu class, the Japanese version, was very much in favour, but the Japanese have great restrictions upon what they can manufacture and sell in the way of defence equipment. This is a holdover from World War II. Believe it or not, they have to get permission from America to sell us anything of theirs. So the short fin Barracuda, the French design, was the one that was selected. There were a few problems with the short fin Barracuda, however. It was a nuclear class submarine, nuclear design, called a Submarine, that the French were currently building. There are 3 major builds with submarines going on around the world at the moment, the Western world that is. The French are building the Submarine class, and from cutting the steel to putting the submarine into service is taking 15 years. The British are building a class of submarine called an Astute, and again, from cutting the steel to putting the submarine in service is taking around 10 years. But the reason for that is that the British have a deliberately slow build program so that they can retain the skill in the shipyards. The third class is the American Virginias, the 774 class submarine. They're being built at 2 locations, Huntington Ingalls Industries at Newport News in Virginia and Electric Boat at Groton in Connecticut. And their build time is 44 months because they're building the bow in Groton and the stern in Newport News, and then they marry it up. Very effective. With the Barracuda type, again, the French said, just take out the reactor and put in a diesel. So we were looking at that. That was given quite a bit of consideration, despite the fact that the Defence Department said, no, we don't really want the French design for a number of reasons. The French wanted it built in France. We wanted it built here. The French wanted us to use their electronic systems. We have our own electronic systems. The French wanted us to use their weapons. We have our own weapons. The submarines of today in the Western world, well, the 3 of the Western world, Canada, the United States and Australia, utilise a torpedo called a Mark 48 Mod 9 Seabass, and they're built down at Garden Island here. We export them to the US and Canada. People don't know that. We don't want to use the French Su-90s. While they were a good heavyweight torpedo, they were not what we wanted. They also wanted us to use their Exocet missiles. We currently use Harpoon missiles, and the new submarines will also launch Tomahawks. We didn't want that. So an impasse developed. And in 2015, the Abbott government decided, we've had enough of this, let's look elsewhere. We are now going to look at nuclear submarines. And an agreement was hit in 2021 forming AUKUS, the Australia, UK, US alliance. AUKUS has 2 pillars. Pillar 1, nuclear powered submarines. Pillar 2 is technology. The US and UK will share nuclear propulsion technology with Australia for the construction of nuclear powered submarines in Australia. The Royal Australian Navy will acquire at least 8 nuclear-powered submarines armed with conventional weapons. I stress conventional. We are not a nuclear power. We don't have nuclear weapons. The technology pillar was aimed at improving joint capabilities and interoperability, focusing, as you see, on cyber capabilities. Artificial intelligence. Artificial intelligence is something the submarines have been using for a long, long time. Number of quantum technologies. Our undersea capabilities are less well known, less well defined. And a couple of countries, Japan, South Korea, India, Canada and New Zealand, applied to become part of Pillar 2 of the AUKUS agreement. The only country that looks like getting the nod will be Japan. I don't know if you're aware of this, but the Americans and the New Zealanders don't talk to each other. They have a very big rift between their defence departments. They do not share technology at all. The only countries in the world that operate nuclear submarines are the 5 permanent members of the UN Defence Committee. The US has 70, Russia has 45, perhaps. China has 14, perhaps. The United Kingdom have 11 and France have 10. The only non-member of the alliance that has nuclear submarines is India with 2. They have 2 locally built nuclear submarines called Arahants. The Indians were very smart. They went to Russia and said, we wanted nuclear submarines. So the Russians leased them an old submarine called a Komsol, which was a NATO code name was a Charlie class. They were very noisy, very clunking machines. But the Indians didn't want it for that. They wanted to get the nuclear technology. And they basically reverse engineered their own reactors and are now building their own submarines. As I say, the countries that have nuclear powered submarines are limited basically to the main Security Council of the United Nations plus India. Now, when I say Russia has 45 nuclear submarines, they probably have about 20 that are seaworthy. 2 years ago, they had a submarine called the Baz, which means bear. It was in the shipyard undergoing an overhaul and was repossessed by the local city because the shipyard hadn't paid their power bill. This happens constantly in the USS, or in Russia, I should say. With China operating 14 nuclear submarines, a lot of them are very old. They've been reverse engineered. That is, they've got Russian submarines from the 50s and 60s and built them to their specifications. Not to say that they're not worthwhile opponents, they probably are, but people like to pump themselves up. And having said that, one of the controversies surrounding the purchase of nuclear submarines is the absolute lack of knowledge that people have about nuclear power. This is a diagram of a nuclear reactor, what's called a PWR, pressurised water reactor, for the US Navy. It powers their aircraft carriers, it powers their submarines. Between those 2 solid black lines to the left of the picture, you'll see the reactor, the control rod motors, the pressuriser and the steam generator. That is the nuclear reactor. All a nuclear reactor is a heat source to boil the water for the kettle. As you can see, there's an enclosed water cycle within that reactor. The pumps run it through the reactor where the isotopes will heat the water. The pressuriser will put an absolute pressure around about 380 bar, 4000 psi onto that water to make the heat hotter, if you can understand that. That hot water will then pass up through the steam generator. On the other side, you'll see the motor condenser. And there's a pump sucking water in from the ocean that will then be distributed around through into the steam generator, where that super hot water from the reactor will convert that water into steam. That steam will then go down to the main turbine through the reduction gearing, the clutch, the propulsion motor and the thrust block to drive the propulsor. Submarines don't have propellers. They have a pump jet propulsor, a rotor and a stator and a shroud, like a jet ski. Secondary is the turbo generator. That steam, or that hot water, will come off there, the hot steam will come off there into the turbo generator, and that'll run to provide power. Submarines have two electrical power systems, and one is called hotel power, the other is called military power. Military power is the power needed to provide for your sonar, your weapon systems, your navigation equipment, your communications gear. Basically stuff you can't buy at Harvey Norman. The hotel power is used for such things as your galley to cook your meals, your air conditioning units, your fridges, your freezers, stuff you can buy at Harvey Norman. So they're the two power supplies that are going to come off through there. Through the motor generators, there's also a battery. The battery's not overly large, but it is an emergency power supply. If something happens, they can do what's called a scram, shut the reactor, go onto the battery, get the submarine up. Simple as that. The whole context of AUKUS is that the only part that will not be built in Australia is the reactor itself. The nuclear reactors will be built by Rolls-Royce out of the UK. They'll come out here as an absolute sealed unit, and it's literally a plug and play. Build the submarine, put in the reactor, plug into the power supplies, and away you go. That's all there is to it. It's very simple, it's very cost effective, and it's very, very, very powerful. When Australia announced the AUKUS project, we're going to get nuclear submarines, up popped the French again. Woohoo! Here's our Submarine class that we offered you before, nuclear powered submarine. Why don't you take our submarine? And the Australian Navy said no. And there's a reason for that. The French submarines use a different propulsion to what we would consider to be a standardised nuclear reactor. Uranium, when you dig it out of the ground, has three isotopes, U-234, U-235 and U-238. 99% of the uranium ore is U-238. 0.7% is U-235. U-235 is what's called the active component. That is the component that causes the radioactivity, that causes the heat, that makes everything work. Uranium is enriched. That is, you strip away the 238 and the 234 to leave the 235. Now, as you can imagine, that is a reasonably complex and expensive procedure. We do not have that facility in Australia to do it. That's why the reactors will be built overseas. The other component is this. The French submarines used LRU, low enrichment uranium. That is, it's enriched to only about 5 to 7%, which means the submarine has to refuel every 7 to 10 years. The British and the American reactors use high yield uranium that is enriched to 93%, which means over the 35 plus years life of that submarine, it will never have to be refueled. It's a bit of a no-brainer really, isn't it? So it comes down to what are we going to get? The Americans are currently building the Virginia class. As you can see, 115 metres, 7,900 tonnes. I've been on these things and they're incredible. They're incredible. We actually refer to American submarines as Sherwood Forest because it's all wood panelling throughout and the overheads are green. It's like you're walking through the woods. Here we are, Sherwood Forest. As you see with the Astute class, very similar, 7,800 tonnes, 97 metres. However, you can see the Astute's a lot bulkier than the Virginia. The difference being the Americans look for the comfort of the crew. They will work out how much crew we're going to need, build their accommodation space, and then we'll build the vessel around it. The British will build the vessel and stuff the crew into every spare space they can get. And that's why American ships are a lot bigger than the British ships, because they're looking at crew comfort. Similarly, the Astutes, well, both submarines will carry 38 weapons total. They have 6 tubes in the bow. The Virginias only have 4 tubes in the bow, but they have what's called a VPM, a Virginia Payload Module, which is 12 vertical launch tubes. In the American submarines, they can fire every missile they have in their inventory out of these launches. Tomahawk, Harpoon, Subrock, Asrock, you name it. They can fire it out of their submarines. We would only look to have things like Tomahawk and Harpoon, which we currently can fire out of our torpedo tubes. But with a vertical launch, that leaves the tubes just for torpedoes. The torpedoes are 533mm, 21 inch. As I've said to a couple of you this afternoon, anything below 21 inches is small arms. The Americans run the Virginias. They have currently 28 of them in service. They've been in service since 2004. Phenomenal submarine, very capable submarine indeed. They had a build rate of what they call a 1-2-1. That is, we'll build 1 this year, 2 next year, 1 the year after. The Biden administration has told the Navy to up it to a 2-3-2 program. So they'll have 2 this year, 3 next year, 2 the following year, and so on, until they get the number that they want. They don't know how many they want just at the moment, but they'll keep building them. The other thing the Americans have done is build them in what they call blocks. They're currently up to block 5. That is what most people would call a software stop point. So all the block 1 boats have the same capability, if you like. The block 2s are a little bit more capable, block 3 is a little bit more, and so on. But as the submarine goes in for an overhaul, it will be upgraded. So the current block 1 submarines have been upgraded to block 5s. So in 10 years' time, they'll all be up around block 9. They're a very, very potent weapon. As you see from the cutaway, spherical sonar in the bow, torpedo tube set back from the bow on a slight angle out to the sides, the VPM behind the forward intense bulkhead where they've got the vertical launches. You'll see that the reactor is only a small compartment, but the turbines take up nearly a third of the size of the submarine. They have crew accommodation, officers accommodation. All American naval vessels have a fast food outlet on board. Believe it or not, I served on an American submarine in 1983-84 and we had a McDonald's on board. Now, it's not what you think. Yes, you can go there and you can buy a Big Mac. You can go to the cafeteria and have a free Navy meal. But you can go to McDonald's and buy a Big Mac. But the money that you pay from that Big Mac goes into a fund for the widows and orphans of naval personnel. Worthwhile project. They make hundreds of millions of dollars a year out of it. They're a very capable submarine. Someone spoke to me about raising a periscope. Periscopes you just put up every now and then. You don't really need them. Modern submarines have what's called optronics. It's a non-hull penetrating mast. You just poke out of the water, rotate a camera, take a video, pull it back down. You can play it on multiple screens. You can stop the picture, you can break it up, you can zoom in on it. I'm sure you all watch CSI or something like that on TV and they can do all these wonderful things with computers and electronics. Not. In reality, it takes a fair bit to do it, but they can do it on the submarines. As I say, they're built at Huntington Ingalls in Newport News. The Americans have told us they will not build submarines for us, for one very good reason. As I say, they have 2 yards. Huntington Ingalls here at Newport News is currently building the Virginias, but they also build the American aircraft carriers there. So that takes up a lot of their time. There's currently 2 under construction there at the moment. The Second yard is Electric Boat at Groton in Connecticut. They're not only building the Virginias, they're also building the Columbia class, the new ballistic missile submarine for the US Navy. So their yards are full. They will not slow down their production of submarines to accommodate us, and we have to accept that. The British submarine is the Astute class. I've been on a couple of these submarines. I've been on one that I consider has the best name a submarine has ever been given, and that is HMS Audacious. I mean, what a name. What a name to give to a submarine, you know. The British have this penchant for anechoic tiling. They put these rubber tiles on their submarines to reduce the impact of active sonars on a ship. As I say, a ship transmits ping on the sonar. It'll strike an object, reverberate back to the ship. They know the speed of sound through water, 1100 feet per second, and they can calculate a range. But if they transmit and it strikes an object, the submarine, and starts to head back to the ship, but it doesn't have the power to get back, and that ship transmits again before that pulse returns, they don't have contact. But the submarine has picked it up. It has heard the ping, and that's what we do. We'll go and sit out of the range, let them ping away. We can listen to them. Very good. With the anechoic tiles, it absorbs some of the pulse. So when the pulse hits, let's say it hits at about 70% power and it'll come back at 65% power, it's now going to come back at about 35% power. So that reduces the range. Again, the cutaway of the Astute carries the Tomahawks and the Spearfish torpedoes, which are the British equivalent to our 48s. The Brits like to give you analogies in here. It's equivalent to 65 blue whales, longer than 10 double-decker buses and all this sort of thing. But they've got a comment here that says the crew will eat 16,000 sausages and 1,200 Weetabix for breakfast on a 10-week patrol. I can assure you submarine sailors do not eat Weetabix. There's no milk on a submarine. On the submarines we have a saying, if you want milk, it's in the cow tied to the banana tree in the tube space. You ain't going to get it. Simple as that. The steel hull here, as it says, it's 7-inch thick in places. And it is. The submarine's pressure hull on the old Oberons was 27.5mm thick, except for the engine room where it was 100mm thick because it acted as a giant heat and noise sink. And the same with these modern submarines. They will increase the thickness of the hull around noisy machinery to act as a noise sink. There you get an idea of the size of their submarine. You can see that line under the top of the casing, that's about the water line. So they're like an iceberg. Most of it is below the water when it's on the surface, which is very rare. They're built at Barrow-in-Furness in Cumbria. And if anyone's ever been there, it's a very unattractive place. All their British nuclear submarines are based at HMS Neptune at Faslane in Scotland. I can tell you I've been to Scotland, I've been to the North Pole. Scotland is colder. You got to admire the jocks, they all wear kilts and the thistles are this high. Having been told that the Brits won't build the boat either, because the yard at Barrow is not only building the Astutes, they're also building the new British Dreadnought class ballistic submarines. So the submarines will be built in Australia. They will be built to what's called an AUKUS design. This is basically, as they say in the trade, an artist's impression of what it should look like. Teardrop hull, single screw. You'll see the planes in the stern are on an angle rather than vertical. They're called a cruciform, and it enables you to drive the submarine by using a joystick. They're very, very easy to drive. They should be built in Osborne in South Australia. There have been moves by Civmec to have them built here at Henderson, and by another company called Forjax to build them in Newcastle. Givens and Druthers, my personal choice is they should build them at all three yards. Why put all your eggs in one basket? Build them in three different yards. This is the Osborne Naval Shipyard. It used to be known as ASC, the Australian Submarine Corporation. You'll see above the blue crane, to the left of the blue crane, is a small pier leading up into a small shed. That's where the Collins class submarines were built. This was originally a company called Eglo Engineering. They built ferries for the Kangaroo Island run, and the South Australian government and the federal government both clubbed together to give them money to build what's called the synchro lift, which is that little pier you see. Submarines are built in the shed, they're rolled out on a railway track onto the synchro lift, which lowers down into the water and the submarine sails clear. To the right of that, you see a bigger synchro lift, and that's where they built the air warfare destroyers, in that big shed that says Osborne Naval Shipyard. The Alvaro de Bazan, the F-100 class frigates, the hulls were built in Spain, at El Ferrol in Spain, put on a heavy lift ship and brought out to here, put into the shed, and all the components were built by companies all around Australia. And they were trucked to Adelaide, fitted into the ships, and off they went. This is the way of modern shipbuilding. Now, if you look to the right, you can see a building with 20 written on it. That is a fabrication shed where they take all the bits and pieces. I'll tell you now, the first time I went there, that was the Bikie headquarters. They had all that land, and they had about a 20-foot high fence, big wooden fence built around it, like railway sleepers. And you couldn't get in there, so the government just moved in with a couple of bulldozers and just pushed it all out. We're taking this, away you go. I don't know where they are now. But this is quite a capable shipyard. They not only built the Alvaro de Bazans, they also built the two big helicopter carriers the Australian Navy currently runs, the biggest ships the Navy's ever operated. Now, the submarines themselves. Okay, what does a submarine do? We have a saying in submarines: you didn't see us, we weren't there. They're excellent for surveillance operations. I think one operation I can tell you about happened in the early 70s. The British withdrew their forces east of Aden, and when they withdrew from Aden, the Russians moved in, and they built an air defence network. I was on one of the two Australian submarines that went up there. For 93 days, we sailed backwards and forwards, about 5k off the coast, with our electronic intercept masts up. The Americans were flying aircraft around the place. This place lit up like a Christmas tree. At the end of our time there, we had a chart of Yemen with the entire Russian air defence network mapped on it. That's what intelligence is about, and people don't realise that. They don't. How did you know that that was there? Don't worry, we know it's there. Now, submarines cannot be employed to convey heads of state on official visits. They cannot be utilised to host official functions for visiting dignitaries. They are of limited use in humanitarian relief missions. Submarines are solely a weapon of war. That's what we do. When you first join submarines, you are told we are in the business of being dangerous. If you don't like it, go. You've all got to accept it. In the submarine world today, it is a very unique, branch of the forces, if you like. We refer to ourselves as the deep elite. There are around about 13,500 people in the Australian Navy today, of whom there would be less than 500 fully qualified submarine sailors. You know, when you go onto a submarine, you are literally hand-picked. You're not there because you're making up numbers. You're there because you've been trained to do a particular job. You're going to do a particular job. If you can't do it, they'll boot you out. Simple as that. Submarine sailors get paid twice as much as surface sailors, because when you're out, you're out. You're out for 90 days dived at a time, 3 or 4 times a year. It's hell on the family, but by gee, it brings the money in, and that's what it's all about. Submarine sailors are unique. They don't panic. They don't stress. They don't fuss. They're the most laid-back people you'll ever meet. They've got the wickedest sense of humour you'll ever find. I'll tell you a little story about this. We had a young officer come on board to do training. The captain we had was a nice young guy. Tugboats and ferries have skippers, submarines have captains, and his name is Sir. And this one particular captain we had, he loved Monte Carlo biscuits. So every time we got cream biscuits on board, I had to sort out the Monte Carlos and put them in a box for him. We had this young officer come on board. He was doing his off-watch security checks. He walked into the engineer's mess, where they wrapped him up in duct tape and threw him down the engineer's store, telephoned the control room and told them we're holding this guy hostage. The ransom is 22 Monte Carlo biscuits. So the captain had to give them their Monte Carlo biscuits to free this guy up. Now, everybody took it in the humour it was intended. But that's what they're like. That's what submarines are like. It's great fun. It's great fun. So if anybody has any questions, I'm only too happy to answer them. We're passive. We don't transmit on our sonars. Surface ships do transmit on their sonars, but it is an international agreement that if there are whales in the vicinity, they will stop transmitting because it does disorient the whales. We like whales. As soon as we see a pod of whales, we'll get in with them because we know the surface ships aren't going to be transmitting on their sonar. Well, it can be. It's when you're at your most vulnerable. To charge the batteries, we have to run the diesels. To run the diesels, we need air, but we don't want to surface. We're going to do a function called snorting. We'll come to periscope depth, we'll put out of the water an induction mast. It's a big ball. Inside the ball is the float head valve that works like a ping pong ball in the snorkel. We'll start up the diesels, it'll suck air in and charge up the batteries. Now we have an exhaust mast and that's billowing out black smoke like a Nissan Patrol barrelling down the freeway. So we keep that under the water to dissipate the fumes into the water and cool the exhaust system. But while we're snorting, we have our above water sensors called ESM, electronic support measures, that will detect and analyse radar and radio transmissions. We are listening for everything. As soon as we hear something, down we'll go. We have grey water and black water tanks on board. The grey water is subjected to what's called reverse osmosis. It's put into it goes into a tank, 4,700 litre tank. There's a membrane in that tank. We put in an absolute pressure. It'll force the water through the membrane. That water can then be used for such things as cooling the diesels, flushing the toilets and so on. But the residue that's left will go into a hopper, and when we get back alongside, that'll go off into a bin. Sewerage. The sewerage will go into a 2,500 litre tank, not much. And when that tank's full, we have to blow it out. And we'll blow it out with high pressure air. It goes through a macerator. So what's coming out into the water is basically a stream of water, straight out. And that'll just blend into the ocean. It's a fertiliser for seagrass and so on. Our rubbish, our food scraps, goes into a disposal unit that will be blown over the side. It's compressed and blown over the side. The fish will eat the food scraps. No problem. Thank you very much, folks.